Here we have a very typical trig question on the finals. We're given a curve and asked to write this curve in terms of a sine function. Now, normally a sine function look like this. So obviously our sine function has some sort of phase shift. So let's go through this analysis and take a look how to solve this one. Here I have a general formula for any sinusoidal function that base curve is sine. Now what we need to do is figure out what the A, B, C, D, those each one of the coefficients would do. So let's go through each one of them. Factor C here is going to squeeze or stretch the curve. Okay, that's pretty easy. Factor D here is going to shift this curve that's been stretched or squeezed either left or right. So this is factor D. And the green one we had it before is factor C. Now the rest of the two for A and B is relatively simple. So A I'm going to put in red. What factor A does is to move this curve really just up and down a little bit. So let's mark it on our curve. So how much we went up, this part is factor A. Okay, one more factor to go. Let's put that one in blue. And then here factor B magnifies this curve. Does not change the shift, it does not change the offset, it just changed the magnitude overall. So if we were to look at a curve over here, we see we don't have any offset, so A is equal to 0, but B is equal to 6 because normally a sine function goes to 1 and minus 1, and here we have a factor of 6. And the next thing left to do is to figure out the C and D, and then we are set. Alright, let's clean out our working space so we have a little room to write. And earlier we said that our general curve is A plus B sine of some sort of stress vector. Now, earlier I said that this is x since our curve itself actually have theta, so let's put the theta back in there, and plus a phase shift factor. We know from the curve that A equal to 0, so there's no offset. And then B magnitude is equal to 6. So our factor now becomes y equal to 0 plus 6 sine of some sort of C. We need to find out theta, which is our x variable, plus a D, a phase shift. And then from here, since we have two variables, you can see there's two variables, C and D, so we need two equations to solve for C and D. And where am I going to find those two equations? What we need to do is pick 2 points from the curve to construct those two equations. All right, let's get to it. What I have here is I picked 2 points for myself in that I don't want 2 involved, so I picked the easiest 2 points on the curve when y value equal to 0. Here's the 2 points, theta is equal to 90, there's 1 point, and 270 is another one. And then what I did is I took what we solved before, A equal to 0, no offset, magnitude equal to 6, and I plugged into the function here. The reason I want to do this is I want to solve C and D, because once C and D is determined, my curve is here, and that's what I'm being asked to do. Now, from here, a lot of students get stuck. So all you really need to realize is that, look, if you have a regular sine curve, let's see if I can draw a sine curve here. And the first 2 zeros happens when alpha equal to 0 or alpha equal to 180. Okay, so basically we're saying, look, when this chunk equal to 0, I have a possibility, and when this chunk equal to 180, it's the next possibility where it hits 0. So the sine of this whole thing of 0 will give me 0. Sine of a 180 will also give me 0. The reason that I picked those 2 points, which you don't really have to, but those two are the easiest point that corresponds to the 2 points where I had numbered over here alpha. This is my regular sine curve without any perturbation, C and D's in there. So from there, I'm going to use what I just discussed and continue solve C and D. Okay, a few more steps. We're almost there. Alright, so what I have done here is I said, look, if this chunk inside the sine curve equal to 0, then I will have a 0 on this side because sine of a 0 is 0. And that translates into this chunk alpha here equal to 0. Next point when it hits 0 again is when this chunk inside gets to be 180 degrees. So that's where this line comes from. Now solving from here onward is pretty straightforward. It's the transition going from the sine curve that where we pick the 2 points to this chunk over here that stumbles a lot of students. So hopefully this explanation helps you to go from this step to here. Solving this one together, we have c equal to 1 and d equal to minus 90. So basically the curve got shifted at 90 degrees to the right and the magnitude is 6. So that's the final answer. Hi, this is Dr. Pan recording from Tucson, Arizona. I hope this video helps you. Please comment or share this video. Together we can make math easy again. Have a confident day.